Alright, so welcome to video 2. What we'll do in this video is take a look at example 276.2, so that's on page 276 of the book. This is figure 277.1, which basically draws out the payoffs for that game. And all I really want to do is to have you guys look at this picture in the book in front of you or on the board here and just go over what the different parts of this picture mean. So for each state, the state here can be yy, yn, ny, or nn. For each state there is a payoff matrix which shows you the payoffs for the players given the actions that the players take. The basic idea of this game is this is a Barkov-Stravinsky game which you've seen before, and we saw a variant of it earlier. This is another variant of it, and the idea behind this game is player 1 knows whether or not she wants to meet or avoid player 2. Player 2 knows whether or not she wants to meet or avoid player 1. But player 1 doesn't know what player 2's preferences are, and player 2 doesn't know what player 1's preferences are. Right? And that's what this game represents. It looks complicated. It is more complicated than what we've done before, but it's easily enough understood. So this is what player 2 thinks that the world might be once player 2 observes signal y1. So that's what this blue bubble represents. With the probability 1/2, player 2 thinks this game is being played, so this is the state of the world, and with the probability 1/2, player 2 thinks this game is being played. So the signal that player 2 has observed here is y1, which tells player 1 that the first letter in the state is y. Right, that tells player 1 that she actually does want to meet player 2. So that's like a yes, no. This is meet, the equivalent of that. So player 1 gets a high utility at BB or SS, and 0 when player 2 does not meet player 1. Here, player 1 receives a signal N1, which tells player 1 that the first letter in the state of the world is N, and these two have equal likelihood, these two games. So what player 1 knows in this state of the world, in both of these states of the world, is that she gets positive payoffs, so 1 at SB and 2 at BS, when she actually doesn't end up meeting player 2. So she actually wants to avoid player 2, and she knows that, and so she knows that it's one of these two games that's being played. In red, I have player 2's, these information bubbles. So here, in this left bubble, player 2 has observed the signal by y2, so she knows that she actually wants to meet player 1, so she gets a positive payoff of 1 when it's BB and a payoff of 2 when it's SS, right? Same thing here. And y2 just means that the second letter in the state of the world is y. Now, so far we've always seen examples where the probability of states that could arise given a signal is equal, 1/2, 1/2. But that doesn't always have to be the case. Here, for instance, player 2 believes that with a 2/3 likelihood, player 1 will actually be of type y1 and not of type n1, and that's perfectly fine. So what that means is that when player 2 observes a signal y2, she thinks that it's 1/3 likelihood that this game is being played, and 2/3 likelihood that this game is being played. If you remember the example from last time, the state of the world for tomorrow's weather is rain or sunshine, but it doesn't have to be equally likely, rain and sunshine. Right? It might be that there's a 40% chance of rain and a 60% chance of sunshine. And so you can have these probability distributions being unequal. So here player 2, her information is that she does not want to meet player 1. So the state of the world has an N as the second letter. She doesn't know what player 1's preferences are, but she knows that with the 2/3 likelihood, this game is being played, so this is the state of the world. And with the 1/3 likelihood, this game is being played, and this is the state of the world. So hopefully this makes sense. Please do take a look at figure 277.1 and just read through it or replay this video, and I hope this will make sense. What we'll do in the next video is define this Bayesian game. So it's better if you have either a picture of this in front of you or the book in front of you when we define it as a Bayesian game. So we'll write out the players, actions, signals, beliefs, payoffs, all of it. So see you in the next video.